Well, good afternoon, everyone. I'm so happy to be here representing Georgia Tech and the Georgia Space Grant Consortium. And we are here celebrating day two of World Space Week. And what's super exciting for me about this year is we're focusing on women in space. So today, I think we've got a really awesome panel to talk to you today. One specific woman in space or woman who has a awesome job working with space. Um, we have some folks from ILC Dover in the space system suits division. I probably just messed that up. I apologize, Dan. Um, but we have apologies, Dan Klopp, who is the director of marketing and business development for the spacesuits division or space systems division, excuse me, as well as Danielle LaFleur, who is a seamstress, which I think is a really amazing job to be a seamstress for space. But she's an engineering tech, and she also is a spacesuit cover lay designer. So isn't that the neatest thing? You'll get to hear today from them about the things that they do at ILC Dover to make sure that astronauts are safe in space. The astronauts look awesome in space, that we're able to land well in space and just be safe in space. So I'm super excited to have both Dan and Danielle with us here today. Dan, I guess I'm going to turn it over to you.
Okay. Maybe we should start with a little bit of a description of spacesuits and the different kinds of spacesuits. I think there's some confusion about the different types of spacesuits that are out there. There's two broad categories of garments that could be considered a spacesuit. One of them is what we would refer to as a launch entry abort suit. I've also heard those referred to as IVA suits, intra-vehicular activity suits. I've also seen several other acronyms and names that they go by, but these are the suits that the astronauts put on before they get into the spacecraft to launch into orbit. And then once they're in orbit, they take those suits off and don't put those type of spacesuits on again until they're ready to deorbit, to come back through the atmosphere to land back on Earth. So those are, that's one category of spacesuits. And then there's a whole other category of spacesuits that are referred to as EVA spacesuits. So those are extravehicular activity spacesuits. And those are the spacesuits that the astronauts put on before they go, excuse me, before they go on a spacewalk. So it's a very different type of spacesuit that's intended to keep the astronaut alive outside of the spacecraft for hours on end while they're doing whatever activity they're doing. So in the astronauts that are on the International Space Station today, they have to do a lot of maintenance activities on the outside of the International Space Station, because the International Space Station is 20 years old now, and so certain components are starting to wear out. And so most of the spacewalk missions that are happening currently are for maintenance missions. So those astronauts have to put on the spacesuit, have to go through an airlock, and then they go out and they may replace a battery pack. They may put a new solar array on the outside of the International Space Station. So those are activities that are happening, and the astronaut, it's not possible for a human to survive in space outside of a spacecraft or outside of a spacesuit. So you can think of the type of spacesuits that those EVA spacesuits as sort of a miniature, highly flexible, personalized spacecraft. And those are the kind of spacesuits that I think we'll spend most of our time talking about today. Although at ILC Dover, we make both types of spacesuits, but I think we're probably more famous for making the EVA spacesuits. And for those of you that may not know, ILC Dover has a long history of making EVA spacesuits. We started with the suits that were used on the Apollo moon landings back in the late 1960s and early 1970s. We made those suits for those astronauts, and we've pretty much made every EVA spacesuit for NASA astronauts since that time, including the suits that are currently being used on the the International Space Station. So you want to tell us a little bit about yourself, Danielle, and kind of your role in all of this?
Yeah, so the outer layers of the spacesuit that you see for newer suits, because spacesuits have been evolving lately, and we're trying to make them look a little cooler. I started sewing the what we call Class 1, which is the stuff that goes into space. They make most of the spacesuits in Delaware. I live in Houston now doing research and development, but they sew most of the spacesuits in Delaware that go into space. So that's where I started, and now I'm doing newer stuff.
Okay. Maybe we could talk a little bit about, since I think this is, the people might be interested in how you get into this sort of career. So I'll start by telling my story of how I got into doing marketing and business development for our Space Systems division. I have a very unusual educational background in that I have three undergrad. I was a triple major undergrad, so I have a degree in physics, a degree in chemistry, and a degree in math as an undergrad. But then I went and got a Master's of Business Administration degree with a concentration in marketing. So I have this sort of technical background along with a marketing background. And prior to coming to work at ILC Dover, I worked for a variety of high-tech companies. Started my career with Hewlett-Packard many, many years ago, working on highly technical types of products, marketed to highly technical customer bases, and then evolved through, and it was really sort of a quirk of fate that I ended up at ILC Dover. But that's kind of my background education-wise and experience-wise that brought me to a career in spacesuits. And I have to say that that of all the companies that I've worked for, by far ILC Dover is the coolest. It's really fun working on spacesuits and getting to talk with NASA astronauts about their experiences and what they like and don't like about the spacesuits, and sort of contributing to that whole development effort of future generations of spacesuits. How about you, Danielle?
So I also accidentally fell into spacesuit making. I've sewn pretty much my whole entire life. Didn't get very serious about it until probably after high school, and I decided to get a degree in fashion design. And then after school, I was just trying to get my hands on every industrial sewing job that I could, so I could learn how to sew on any industrial machine I wanted, because they're just fascinating to me. So my last job before ILC, like I've sewn so many different types of things, just been all over the place. But my last job before ILC was working at Under Armour headquarters. I'm in Baltimore, and we worked really closely with the designers and the athletes to create more functional garments, and just working on the aesthetics and making sure everything looked super cool, and just trying to innovate in that athletic wear category. So after that, I was kind of like, where could I do this again? So that I looked up ILC Dover because I've always been up into space and sci-fi things and everything like that. But I mean, there's no way I could be an astronaut or anything like that. So I was like, I wonder if I could somehow sew and also be in the space industry. So I looked up who made spacesuits, and it led me to ILC Dover, of course, and they had an opening for a spacesuit technician. So I was like, okay, I think I'll apply. So I did, and I got the job, and it was so cool. And then I really wanted to I wanted to see if we could make spacesuits look even cooler while still maintaining functionality. And so that's how I ended up here in Houston.
All right, that's a really interesting story, and almost as, or actually even more unusual, perhaps than my path to this part of my career. All right, we had a few questions that came in from from people prior to or when we were advertising this segment, and I think we can jump in and use those questions as a launching off point to talk more about spacesuits. The
Perfect.
first
Sounds
question
good.
we have is from Kashmir in the 5th grade, and they ask, "What are the parts of a spacesuit?" You want to take that, Danielle?
Might need your help because there are a lot of parts to the spacesuit.
Yes.
So you have gloves, you have the upper torso, you have the brief, you have the lower torso, the PLIS, the primary life support system on the back, which we don't make. We only make the soft goods parts of the spacesuits. But yeah, so I do have a glove here for an example, just to show you how many layers. Also, Dan, I know you have that the sample of all the materials from the suit if you want
Hmm.
to show that.
Sure. You want me to start
So
with that?
yeah, let's start with
Yeah,
that.
okay, I'll start with that. So what I have here is a representative, what we call a ply-up of all the different layers that are in the spacesuit. And this varies a little bit from spacesuit component to spacesuit component. So Danielle, in a minute, will show kind of the layers of a glove. But for the main body of the spacesuit, this is sort of what you get. So this outer layer is called the TMG, the thermal micrometeoroid garment, and this is the layer that that Danielle does her fashion design work on, because this is what you see on the outside of the suit. But the spacesuit consists of far more than that. So there's that layer that's on the outside, and and I should back up. The purpose of that layer is for some level of thermal protection. It's always white to reflect as much solar energy as possible, because when you're in direct line of sight with the sun, it can get really hot. So you want to try to reflect as much of that heat as possible. And it also is made of very, very strong material because it's a micrometeoroid protection garment. So micrometeoroids are these tiny pieces of what you can think of as space dust, but they're flying at really high velocities. And so, if one of those were to hit an astronaut, if there weren't this outer protective layer on, it could risk penetrating into the rest of the suit. So that's what that layer is for. And then under that layer are quite a few layers of insulation. This is an aluminumized mylar material. So there's many, many layers of insulation there. And another layer. We have 5 layers of that insulation. And then there's a liner layer that goes between the insulation and the TMG, the outer layer. And then there's a restraint layer. This is made from a non-stretch fabric. And the purpose of this layer is to stop the bladder layer, which I'll show you next, from just ballooning out and continuing to expand. Because the spacesuit is pressurized and it needs that. We as humans need pressure, air pressure against our skin to survive. And so there is no air pressure in space. So in order to survive, you need a full pressure garment, which is what the spacesuit provides for you. But the purpose of this restraint layer is to, as the name would imply, to restrain the bladder layer, which is this layer, from just ballooning out and continuing to expand. And this bladder layer is the layer that holds the air pressure. So this is absolutely critical in, not that all the layers aren't critical, but this is what maintains the pressure inside the spacesuit. And that's pretty much the suit itself. And then we make 2 undergarments that the astronauts put on before they put the rest of the spacesuit on. This undergarment is called an LCVG, liquid cooling and ventilation garment. And this has fine gauge. This is just a small piece of it on this sample, and I don't know how well you can see this in my webcam, but it has fine gauge tubing running all woven through it, and it's a full layer of undergarment that the astronaut puts on, and that fine gauge tubing is then all connected together to a water pump that's in the PLIS, that's a life support backpack, and it circulates water through the suit to keep the astronaut cool. because as I mentioned, when you're in direct line of sight of the sun, when you're in orbit, it can get very hot. So to keep the astronaut cool, you have this LCVG garment, and then underneath that is just another comfort garment. It's just a sheer flexible undergarment that they wear under the LCVG. So that's pretty much the main body of the spacesuit. And maybe you can show some examples of the glove technology.
Yeah, actually, since you brought up the LCVG, I actually did grab one. This one is well loved, so it's definitely not brand new and white, but so this is what the astronauts will wear under their EVA suits to keep them cool because it can get over 250 degrees in the sunlight when they're on a spacewalk. You can kind of see the little tubes that carry the water. And then there's actually some water still in there, but yeah, so this will connect to the life support system and it will recycle the water and circulate it and keep it cool so the astronauts don't overheat in space. But also, since it also does get cold when there's no sun in the gloves, we have heaters and things like that. So I'll show you the bladder first. So this is the glove bladder. This is the innermost layer of the glove. The astronauts will wear a comfort glove, and then if you just imagine this is the whole glove, this is what's on the inside. And this is, like Dan was saying, this holds the air pressure. And this is the restraint. It goes, you can kind of see the bladder inside of there. So the restraint, as Dan said, this is to make sure that this doesn't get overloaded with air and explode or pop or get a leak or anything like that. So this is like the contingency layer to make sure that this one doesn't get damaged or, the astronaut doesn't end up seriously hurt. There are sizing cords because we have a lot of glove sizes. Only a few astronauts will get custom gloves, but so we try to make sure that the fingers can be adjusted to fit anybody as much as possible. And then you have the TMG layer. This goes outside of the restraint layer. You can see that there will be heaters inside these little fingertips here, and you can turn them off and on with this little switch here. Show you guys the inside. Can't really see much, but here's the cord for the heaters. And then we have this silicone RTV on the palm because the astronauts need to be able to grip things in space when they're on a spacewalk, and they need to be able to handle their tools and not have them slip out of their hand. So yeah, that's a glove.
Actually, before you move on, Danielle,
Yeah.
Let me just grab something from my my office here.
All right.
Wanted to show the evolution of, so although spacesuits for the last 30 years have looked pretty much the same, there are actually some pretty big differences at sort of the technical level. So if you could hold up the palm of the TMG layer that you had before, and look at how that is. And what I want to hold up here is the palm of an much older design glove. This was a material called Vectran, and now we use a silicone rubber sort of thing. This has, you can see that the fingertips on this one are somewhat different. Again, if you look sort of from the outside, they don't look that different, but we continue to innovate and add sort of new features and functionality to the spacesuit. So again, if you just see it from the outside, you think, well, that looks the same as the spacesuit did 40 years ago. And actually, there are quite some differences, and we continue to add new functionality and features to the spacesuits, even though they look pretty much the same on the outside.
Yep, that's absolutely right. We're always changing them and trying to make them better, more functional.
All right. So maybe in addition to the layers or the pieces that we talked about, I can talk a little bit more about the PLIS. That's an acronym that NASA uses. It's PLSS. It's typically said as a word, inserting an I somewhere in there, and it's the personal life support system, or depending on whose generation of acronym interpretation you're using, it can also be referred to as the portable life support system. And I forget which one NASA is using now as the official designation of BLIS, but in any case, it's the life support backpack. And there's a lot that goes on inside of that backpack. And although we don't make that at ILC Dover, we've had a partnership with a long-time partnership with another aerospace company that is today called Collins Aerospace. And they're the ones that we've been in partnership with them for more than 50 years now. They made the life support backpacks for the Apollo suits, and they're making the life support systems for the suits that are used on the International Space Station today. And I know just enough about what goes on inside of that to be completely dangerous, but maybe I'll talk a little bit about that. So there's oxygen in there, so you need oxygen to breathe. In addition to that, there is the cooling pump in there that we just referred to. So it's a water circulation pump that pumps water through that LCVG. And then there's a heat exchanger in there that dumps the extra heat as that water is being circulated, dumps it out into space. In there is a CO2 scrubbing system. So every time you inhale, you're inhaling oxygen, but when you exhale, you're exhaling a good bit of carbon dioxide, and that needs to be taken out of the atmosphere. It can't just collect inside the spacesuit. So there's a CO2 scrubber system in there. And there's, in addition to all that, there's pressure regulators that regulate the pressure in the suit to keep it at an even pressure as more oxygen is being bled into the suit. So those are kind of the major components of what's inside that life support backpack. And as I say, that is a really major component of, it's actually the single heaviest component of a spacesuit. If you look at the complete assembly of a spacesuit, the bits that we make at ILC Dover are a little less, not quite as heavy, not near as heavy as that life support backpack. But that's all the stuff that's in there is necessary to keep the suit functioning properly so that the astronaut stays alive and healthy and productive in space. So the next question we have, moving on to the next question, is from Zaire, also a fifth grader. And they asked, is there a special type of seamstress training you need to create spacesuits? So that one's all you, Danielle.
I wouldn't say there's necessarily spacesuit training. If you're interested in the job, I would say if you're thinking about a career in spacesuit sewing, I would highly recommend learning how to sew on every type of material you can get your hands on, every type of industrial machine you can get your hands on, just so you're familiar with how the material moves and how you need to be able to handle it. It will give you a huge advantage. Drawing, color theory, AutoCAD, 3D modeling are all very useful skills for that as well. I would also say get very comfortable with hand sewing, because there is a lot of that if you're doing class 1. Stuff that goes to space, there's a lot of very small meticulous details. The tolerance for sewing a spacesuit ranges anywhere from like a 1/16 of an inch to a 32nd of an inch. The tolerance is the margin of error you have in your stitch rows. So it's like the width of a hair. So get really good at sewing, I would say. That will give you a huge advantage if you ever think about getting a job sewing spacesuits. Pattern making knowledge, I would say, is also very, very useful.
Yeah, you bring up a good point that there is a lot of interaction that goes on between our seamstresses and our design engineers, because our design engineers are by and large mechanical engineers, but many of them do not have experience sewing. So they may design something on their using their CAD program that is almost impossible to actually make. So there's this sort of back and forth that goes on between our design and development engineers and our seamstresses to sort of perfect, this is what, from a functional standpoint and a size standpoint, this is what we want. But then we need the input of our seamstresses like Danielle to kind of bring our engineers back to reality and say, well, you can't
Yes,
make it that way, but if
yes.
you designed it this way, we could make it.
The seamstresses are absolutely vital because they'll be able to tell you how the machine will handle the fabric and what it can and can't do. So yeah, definitely a vital part of the process.
Okay. And we could move on to the next question we had, which is the question we get all the time in these sort of presentations, is where do the astronauts go to the bathroom? So first of all, when they're in the spacecraft, there are special space toilets that are like inside the International Space Station. But I believe this question from Lyra in the second grade was more directed towards when they're in a spacesuit, what happens. And Danielle, you want to take that? There's a garment we call the mag.
Yeah, so the mag is essentially a giant adult diaper that the astronauts will wear for sometimes over 8 hours on a spacewalk. This is what it looks like. Yep, they have to go to the bathroom in that when they're on a spacewalk. I think a lot of them prefer to not go to the bathroom if they can help it, because it's just kind of an uncomfortable feeling. But, got to do what you got to do. If you're an astronaut, you have to check your pride at the door. That's for sure.
That is certainly true. That's one thing that
Yep.
I've learned about since I've worked for ILC Dover is all the astronauts that I've interacted with are very matter of fact about their bodies and their bodily functions, and that's it just comes with the territory when I think when you train to be an astronaut. Oh, and by the way, MAG is an acronym. We love acronyms in the space world. It's a three-letter acronym that stands for Maximum Absorbency Garment. So, as Danielle said, it's basically an adult diaper. So that's always a fun and games question. We got a question from Musa in the second grade. They asked, how many years of school do you need to be an astronaut? Actually, neither Danielle or I are qualified to answer that question since neither of us are astronauts. We deal with astronauts, we talk with astronauts all the time, but neither of us are astronauts. And ironically, I think I'm probably too big to be an astronaut, and Danielle is too small to be an astronaut. So it's kind of funny when Danielle and I stand next to each other, we have quite a difference in our heights, but I'm a little over 6'2", and it would be we might have a size of spacesuit that might fit me, but it would be
I
really
think we
tight.
would.
Yeah, but for Danielle, we don't have a size that'll fit her. What are you, around 5'1", something like that, 5'2"?
I'm 4'11", 5 feet on a good day.
Oh,
I think we do
okay.
actually have suits that fit me, but I couldn't personally be an astronaut because I get very car sick. I would not pass astronaut school.
Yeah. So we can't really answer that question, although I do know that from talking to a variety of astronauts that I've spoken with over the years, that they come from a wide variety of backgrounds. So most have advanced degrees in one field or another. A lot are engineers, but not all. There are astronauts that have been geologists, astronauts that have been biologists, lots of different technical fields that they come from. And they do train for a long time, particularly if they're going to do a spacewalk. They train for literally years in what NASA calls the NBL, the Neutral Buoyancy Lab. It's a giant swimming pool, basically, that's got replica pieces of the International Space Station sunk inside in the pool, and they go into a spacesuit, and then the spacesuit is adjusted for buoyancy, so that because it's inflated with air, it wants to float to the surface, but they adjust the buoyancy of the spacesuit with special weights to make that suit neutrally buoyant. So it simulates sort of a spacewalk where you're neither sort of floating to the surface or sinking to the bottom. And it allows them to do some training for the sort of maintenance missions that I was referring to before. And actually, the neutral buoyancy lab is about, I'm trying to see where Danielle's sitting, probably about 10 miles over her right shoulder from where she's sitting right now. Maybe not quite that far as the crow flies, but yeah, it's back there. So our facility, the ILC Dover facility in Houston, where Danielle is sitting now, is located right across the street from the Johnson Space Center. Well, almost across the street from the Johnson Space Center. And that neutral buoyancy lab is a piece of the Johnson Space Center campus that's there. So that's part of the training they do. But again, it's to really answer that question, we need an astronaut on the line. Okay, we have, what other questions do we have here? How old is the universe in years? Oh my goodness. That came from Marcus in the 5th grade. Again, a question that Danielle, neither Danielle or I believe are qualified to answer. Neither of us are astrophysicists. So we're both involved in sort of the space suit and human space exploration piece of the space industry, but don't really study, or at least I don't believe, unless you're holding out on me, Danielle, and there's something you haven't told me about yourself.
I wish, Dan.
Yeah, exactly. I wish too. Neither one of us is Neil deGrasse Tyson. Let me put it that way. So those are the questions that we had submitted ahead of time. I'm not sure if any of the attendees listening have any additional questions they'd like to add to that.
Dan, I think we did have a question about someone was asking if they could design suits like high-end luxury suits like Gucci or something like that. I did want to bring that up because there are a lot of people that will design spacesuits and put their designs on the internet, and they look really cool. And I wish we could do stuff like that. But I think it's really important to have some knowledge of the inner workings of the spacesuit and how it has to function. Because the engineers who built the spacesuit, you have to work really closely with them because they know what can and cannot be covered up with a fancy design where you can and can't put lines, which would make it look slimmer, which would be totally awesome. But sometimes it's not always possible. So I wouldn't say no, because I mean anything can happen. You could be a big name designer and work with engineers. But for now, I don't know if that is a thing that really happens too often. You'd probably have to be in the space industry to do that.
Yep.
Do that job very well.
Right, and that's you bring up a really good point, Danielle, about sort of fashion and the what I would call the crossover between science fiction and science reality. In a lot of science fiction shows, you'll see these sorts of spacesuits that look almost like a scuba diver wetsuit. They're very form-fitting, and there has been some work that is going on in what we term mechanical counterpressure suits. So these are spacesuits that instead of putting force against your skin with air pressure, as I mentioned, the suits we make today, and all the spacesuits today are pressurized because you need pressure against your skin to survive. And there has been some work done in these mechanical counterpressure suits, but they would take a pretty big breakthrough in material science, sort of active fabrics, to make those a reality. So while they look really cool in sci-fi shows, and they're very slimming, as Danielle was referring to before, they're just not practical given the state of the art of material science in today's world. So the first job of a spacesuit, above and beyond how cool it looks, is to keep the astronaut alive. So
the focus will
Those are the
always be on functionality and safety over aesthetics every time.
right.
Yep. Yeah,
And
so if
we
you
do
have
have some additional questions that have been submitted.
great,
Probably.
awesome.
And I don't know, so one of the questions, it may or may not be one that you guys can answer, but I think it's a really great question. It's from a second grader named Princeton who says, how much money do you need to go to outer space but not be an astronaut? I want to go to space, but not be an astronaut.
I think
Wow.
nowadays with space tourism becoming popular, I think if you want to go to like low Earth orbit, I think what was it, around 250,000 or $400,000? But if you want to go to the space station, I think they used to send civilians into space for around 40 million per seat. So I don't know if they still do that, but it could happen again in the future. Who knows?
Well,
But what
and
a great
there,
question.
yeah, beyond that, there, so you have to sort of define of what you mean by going to space.
Yep.
So both Virgin Galactic and Blue Origin now are just had their first suborbital flights. So that's where you don't go into orbit, but you get outside of the Earth's atmosphere. So it's what we would term in the space industry a ballistic flight. So you just go up and go down, come back down again, and you don't completely circle the Earth multiple times like you would in an orbital flight. And those flights, as that piece of the space tourism industry gets more developed, those I'm pretty sure the price on those seats will come down quite a bit. However, that said, if you want to go to orbit, like the four astronauts that are non-professional astronauts that just took the flight on the Inspiration 4 mission, I think those seats were somewhere around between, I think Danielle had the numbers about right from what I recall, somewhere between 250,000 and 400,000 each. Now, one of those seats I think was donated to, or maybe two of those seats were donated so that the people that actually went didn't have to have to write the check for that much money themselves. So they were donated by a couple of organizations. But for sure, as space tourism becomes more popular and the flights become more frequent and more companies participate in that, we know of several other companies that are developing spacecraft and commercial space stations that are planning to be human certified and put in orbit within the next several years. The price of all this will come down. But right now, it's still pretty expensive to go to space.
Another question we have is, and I'm guessing this will depend on which spacesuit they're referring to, but how much does a spacesuit weigh?
Okay, I'll take that one.
Okay.
So today's suit that's called the EMU. So this is a EVA spacesuit. This is the suit that's used today on the International Space Station. That suit here on Earth, depending on how it's configured and what size it is, weighs somewhere around 300 pounds here on Earth as it's ready to go through the airlock on the International Space Station. And that, so the interesting thing about that is that's here on Earth. So that's in what we would call a 1G environment, one times the gravity of Earth. When you're in Earth orbit, you're in what's referred to as microgravity. So essentially the suit goes to 0 pounds. Now it still there's a difference, and this maybe gets too technical for this audience, but there's a difference between mass and weight. So mass is a property of matter. So the suit has a certain mass. So say it's so 300 pounds would be about 125 kilograms, something like that. So it would still have a mass of 125 kilograms, whether it was here on Earth, whether it was sitting on the surface of the moon, or whether it was in microgravity of low Earth orbit. However, weight is a force, and it's a function of gravity. And so that same suit that weighs 300 pounds here on Earth weighs essentially 0 in orbit and would weigh 1/6 of that if it were on the moon. Um, that's in rough numbers, that's about the weight of today's spacesuits. The spacesuits that we're developing as the next generation of spacesuits that we hope will take astronauts back to the moon, those will be considerably less weight. We're shooting for something less than 250 pounds for those suits. Now, part of that compromise that you reach in getting to a lower weight suit that's more mobile for walking around on the surface of the moon is they won't have the length of life support that the current EMU has. The current EMU can support a spacewalk of more than 8 hours. They typically today only last between 6.5 to 7 hours typically, but in terms of the capabilities of the suit and Bliss, the life support backpack, they're capable of supporting life for more than 8 hours. These next generation of spacesuits that we're designing to go back to the moon, those, while they'll have considerably less weight than today's EMU, they'll also have less life support total time. I hope that answered the question without going into too much detail.
Oh, I think that was a great answer. And as non-technical, answering technically, I think you did great. I do have two more questions, and hopefully these will take us to around 3 o'clock in the hour mark. But for either one of you, I don't know which one is best to answer this, but what was the most challenging project that you've worked on, and how was that challenge overcame?
Well, I'm going to let Danielle take that one.
Oh, I mean, I would probably say the stuff we're working on now is the most challenging because we haven't attempted it before. I think not being afraid to make mistakes is really important because you have to get through all those mistakes in order to learn and to progress your project. Yeah, I'm not really sure how else to answer that question, but I would say the projects we're currently working on now have been the most difficult, and just figuring out, from my job's point of view is, how to integrate the cover layer with the undersuit layers harmoniously so they work together and it's not impeding any functions of the suit itself has been pretty challenging. A lot of things will look good on paper, and then when you do them in real life, they will just look really weird. And it takes a lot of iterations to get to the final product, and a lot of testing, a lot of material testing, because there's only so many materials that can be used in a spacesuit because they all have to go through rigorous testing in order to be certified for space flight.
And I'll second that, that the current project that we're working on for the next generation of spacesuit has been the most challenging. I'll tell a little anecdote here, a little story. It was 3 weeks ago now. Nicole and I were in our office in Houston. I had taken a business trip down to Houston, and we were both still in the office. Now, this was a sort of an unusual day. I'm not saying that every day we work this length of hours, but we were still both in the office at after midnight on the day before a test. Actually, I think it was after 1 in the morning. It was pretty late.
4 in the morning.
Yeah, Danielle was there after I went to bed, and that was a special push to get ready for a test that we were running that next day. And so that was, it can be a challenging job at times, but it's also a rewarding job. After that late night that we had, or more correctly, early morning, the wee hours of the morning, the test came off flawlessly the next day. So there was a lot of personal satisfaction that I know,
An
speaking
awesome
for myself,
effort.
and yeah, that was a great team effort that went into between us and the Collins Aerospace team. They were also there working on the Bliss till very late at night to get ready for that test a couple of weeks ago. Yep.
And I think that some of what you guys were just talking about leads right into this very last question. But how how many teams does it take to design a full suit? I mean, I'm understanding as you guys described lots of different components, but how many teams does it take to design the suit? And then once it's designed, how long does it actually take to make a suit?
Dan, do you want to take
Ooh,
that one?
yeah, I'll start with that one, but I may need your help on the
Okay.
making it side. So to design a spacesuit, so as we mentioned earlier, there are different major components that go into a spacesuit. There's sort of the way we think of it, two major components. There's the pressure garment assembly, which is the piece that we make at ILC Dover, and then there's the life support backpack, the PLIS, that currently Collins Aerospace makes that piece. And speaking from sort of the perspective of the pressure garment assembly that we make at ILC Dover, we have a team of I'm guessing about 20 to 30 engineers that probably at one point or another touch different components of the spacesuit. Um, and on the Collins side, on the life support backpack, I know their team is roughly 4 times the size of our team. So if we have 20, say 25 people working, engineers and other technicians working on a spacesuit, Collins has about 100 people working on the components of the life support backpack. And then as far as manufacturing the suit, once the design is set, you want to take that one, Danielle?
Well, it's kind of a tricky question to answer because the suits that go into space now, they're made in components. Like someone would be working on a glove, or someone will be working on like a boot, and it just depends on what's needed for the space station or for a training run or whatever. So it's kind of a complicated question. We don't make the suit all at once.
Yeah, because it is modular. And also, when NASA buys them, they don't buy a complete suit at once. They buy a component at a time. So a lot of the suit components get sort of reused between different and resized for different astronauts. So depending on what astronauts are needing to take a spacewalk in the coming months, they may use a certain size upper torso, but mate that to a different size set of arms than that upper torso had previously mated to it, with a different size set of gloves. So there's a whole inventory of spacesuit components. And so when we're sort of refreshing or adding to that inventory that NASA maintains for spacesuit components, we do that a component at a time. And so we may, make a new set of gloves this month, and the next month we may make a new set of boots, and the month after that we make a new set of arms. So it is a complex question to answer because we don't. Unlike the Apollo era. Now, the interesting bit of history here is going all the way back to the suits that we made for the Apollo astronauts 50 years ago. Those suits were essentially one-piece suits. They were custom tailored to each individual astronaut. So each astronaut had, I believe they had 3 suits each. They had a primary suit, a backup suit, and a training suit. And those were custom tailored to each individual astronaut. So neither Danielle nor I worked in the company all those number of years ago. So I can't say to speak to how long it took to assemble one of those suits, because that was pretty much a one-shot deal that we did back then. But today it's in this with the modular design that we have today, um, it's hard to say how long it takes to make a spacesuit.
I can give an example though of so the gloves. I used to do mainly gloves when I worked on Class 1 in Delaware. Uh, so you have the restraint and the TMG. A different person will be working on this one and this one at the same time. It could take about a month to 2 months. Um, Maybe even faster for the veteran glove sewers. I don't want to. They could do it faster than a month, but typically around a month, I think, is the fastest I've ever sewn a glove, TMG or restraint. So I hope that helps.
I think those are great answers. It definitely puts into perspective, I would say, the bigger picture of everything with the work that you guys do. And I think it's really neat that history that Dan just shared, going from the Apollo era to now. It seems that the modular approach probably is much more effective and probably uh, time I can't even think of the right word here, but it doesn't take, it's not as time consuming as the
Right.
customization for each individual astronaut like you're
Yeah.
describing.
And
So
it's more cost effective for NASA as well.
absolutely, that's very cool. Well, there are no additional questions from the audience that I have. Here, let me come back on come back on camera and thank you both for joining us today, and thank everybody for attending and joining us and watching live. We've definitely happy to have you guys here, and I learned some great new things about spacesuits as well. So I thank you both for taking the time to share all of that with us here in Georgia. And we will also be sharing this stream out on our YouTube channel. So we'll have lots of additional folks watching it in the days and weeks to come as well. So um, thank you very much. And I guess unless there's anything you guys would like to add, any words of encouragement or things, um, we could wrap things
Um,
up.
I could. So
Love it.
since I had a very non-linear and untraditional kind of way into the space industry, I think for anyone who's thinking about pursuing a career in making spacesuits, I would say don't be afraid to set ridiculously high goals, no matter what anybody says or thinks about it. Like, let your goals scare you because of how big they are. And if you're passionate enough about something, the pieces will fall into place and you'll get there much faster if you set very lofty goals.
That's
And
great
I'll add to
advice.
that.
Aim higher.
Mhm.
Yeah, and I'll add to that to say that it's never too late. I'm on my what I would think of as my third career now. Um, I and I didn't get involved in the space industry until after I turned 60 years old. So it's never too late to change careers and to add something else to your sort of personal repertoire of life experiences.
Very incredible. That's awesome. I think that you both have got amazing. I mean, as you both said, you wound up where you are through different paths, and it's incredible. I myself and at Georgia Tech wound up here through a very unconventional path. So, like both of you, setting high goals and don't take no for an answer. Just keep pushing
Mhm.
forward and aim higher. So definitely. But yeah, thank you both very much. And we have had I think, a wonderful stream learning about spacesuits and spacesuit systems. So
Thank you
have a
so much
great
for
rest of your
having us.
afternoon. Yeah,
Thank
thank you.
you. You as well.
Yeah, it was our pleasure.
Absolutely.
All right.
Bye, everybody.
Bye bye.
Bye.